All right, welcome to your final exam review. For this first video, we're going to go way back to the beginning and talk about some linear equations and some linear situations that we might come across. So very, very basic, just to solve an equation, we want to do is called isolating the variable. And what that means is I want to get the variable by itself, and I'm going to do that by doing the same thing on both sides of the equation. Now, not every operation we do involves working with both sides of the equation. For example, in this problem here, the first thing I want to do is distribute my 2 into my binomial x minus 1, which only involves one side of the equation because it's already there. I'm not changing anything. So I multiply that 2 into the binomial. We get 2x minus 2 on the left side and my 10 on the right. Now I want to start isolating the variable, getting it by itself, meaning I do the opposite operation. So for example, I'm subtracting 2 before, so now I'm going to add 2 on both sides. Oops. And that's going to get rid of that minus 2, so we've got 2x is equal to 12. And again, same thing on both sides. I have 2 times x, so we're going to divide by 2 to get rid of it. And so we wind up with just the x on the left side is equal to 6 on the right. So we've isolated the variable or gotten it by itself. Now, you should remember a ratio is a comparison of 2 or more numbers, and there really are 3 ways to write a ratio. One of them is using this word 2 that you see here. Otherwise, our other options are to write something as a fraction, a ratio, or I can write it using this colon notation here. Far away, the most common way that we're going to use it moving forward is this fraction notation. That's really the most common thing we're going to be doing in algebra. Now, once we've got ratios down, I can talk about 2 ratios set equal to one another, and that's what we call a proportion. A proportion involves me going to cross multiply in order to solve. So cross multiply means I multiply through the diagonals. So I'm going to multiply, for example, 2 times x. That's going to give me 2x. And multiply this diagonal as well. 15 times 5 is going to give me 75. Then again, solve by isolating the variable. I'm going to divide by 2, and we do that on both sides of the equation. And so I get x is equal to 75 halves. Okay. And there's my solution. Now, I can do that in a more complicated proportion like you're seeing on the right here. And this proportion has binomials in the numerator. So what we want to remember is when we're cross multiplying, this 20 here is going to multiply the entire binomial x minus 1. So I want to just make sure that I remember to distribute. So distribute means 20 is going to multiply both terms, the x and the negative 1. So we get 20x minus 20. And same thing on this other diagonal, 5 times the whole binomial. So 5 times 2x is going to give me a 10x, and 5 times negative 3 is negative 15. And then we go ahead from there and solve. First thing I'm going to do is subtract 10x on both sides. I want to collect all of my x's together on one side of the equation. And so that's going to give me 10x minus 20 on the left is equal to negative 15 I have left on the right. I can add 20 to both sides of this equation. And so we just have a 10x now left on the left side and a positive 5 on the right. And the last thing we're going to do is divide by 10 on both sides. And so I'm going to have 5 over 10, which reduces to 1/2 as my solution for x. Now that we've got proportions out of the way, I can talk about another special kind of ratio, which is a percent. Now, a percent, we always compare a number to 100. That's the idea of a cent, right? 1 cent is 1/100th of a dollar. So a percent is comparing numbers to 100. Now, there's a couple of different strategies that we can use in order to solve percent problems. One is to make a proportion, and you've probably heard of the idea of is over of. So I want to identify which number is the is, which number is the of, and that's always going to be equal to the percent divided by 100. So in this first problem, for example, I've got 7 is 35% of what number? So I can set up a proportion, and I've got this 35%, so that makes this part easy, 35 divided by 100. Now 7 is the is, it's got this is next to it, so I know that goes in the numerator. And then I've got of what number? I don't know what number, so I'm going to put an x in the denominator for now. And we solve it just like any proportion. I can cross multiply, so 35 times x is equal to 7 times 100. And we divide by 35 on both sides, and so we get x is equal to 20. Okay. Our other option when we're trying to solve percent problems, sometimes I'm going to get a percent as a decimal. Now, what that means, if I see a number that's a percent as a whole number and I want to turn it into a decimal, for example, I do that by dividing by 100. So for example, if I've got 20%, okay, I can divide by 100, meaning move the decimal over 2 places to the left, and that's going to give me this percent as a decimal. So 0.2 is equivalent to 20%. In the same way, if I had something like 4%, okay, again, to put it into a decimal, I divide by 100. I move the decimal over 2 places. So this is going to make this 0.04 as a percent. Okay, so always 2 places. Now back to working with the problem. I can always also, instead of making a proportion, I can kind of translate my problem into words. So the idea is we've got is always going to represent an equal sign. The word of is always going to represent multiplication. And the word what means that I don't know what the value is, so I want to use a variable. So as an example of this, I can see this problem says what percent of 300 is 75. So I've got what, we make that an x. Of 300, we multiply, is 75. So x times 300, I can divide by 300 on both sides in order to isolate my x. And so I get x equals 75 divided by 300, which reduces to 0.25. Now I know that I want to represent that as a percent, so just like we've turned whole number percents into decimals before, we can go back in the other direction by multiplying by 100 or moving the decimal place to the right 2 spots. So 0.25 is the same thing as 25%. The next type of problem we're going to address, moving right along, is the inequality. Now, the one rule we want to keep in mind, the kind of important thing, is that if we multiply or divide by a negative, this is when we want to, there we go, we want to flip the sign over. So, solve it mostly like an equation. First thing I'm going to do, again, distribute. So negative 2 times x and negative 2 times 5. Minus 3 is greater than 3. I can combine my like terms on the left side here, so minus 2x minus 13 is greater than 3. Then we're going to add 13 on both sides, so negative 2x is greater than positive 16 is what I should get here. Okay, yeah, add 13 to both sides, 3 plus 13 is going to give me 16. Now here you notice I am dividing by a negative 2. So anytime we have to multiply or divide by a negative, that's going to flip this inequality sign over. So what was a greater than is now going to be a less than symbol. And so we're going to have x on the left side is less than 16 divided by negative 2, which is negative 8. So here's my inequality. Now the next thing I want to do is represent this inequality on a number line as a graph. So my critical value here is negative 8. That's the number that I want to plot on the graph itself. And when I do that, I want to keep in mind what kind of a dot I'm going to put on my number line. Okay, so we've got the numbers for the number line. Negative 8's right in the middle here. And I'm going to use a dot based on my inequality from the beginning of the problem. So a less than or a greater than sign is always going to be an open circle. And if I have an or equal to, less than or equal to, greater than or equal to, that's going to be a closed dot. So because this problem originally was a greater than, not or equal to, we have that open circle at negative 8. And then x is less than, so I want to shade anything less than negative 8, which is going to be to the left here. Okay, okay. Whew. Almost done. Just some word problems left. So word problems, we want to define a variable. Let's see. Highlighter. Okay, we're going to solve by defining our variable and then writing an equation. So defining the variable just means that I want to make sure that I know what my variable is and what it represents. In this first problem, we have 3 consecutive odd integers. So my variable, or my variables in this case, we'll I've got x, x plus 2, and x plus 4. This is how we represent consecutive odd integers. We go up by 2's. Okay. Now this problem is telling me that the sum of those three numbers is negative 15. So sum means add. And I add those things, the x, x plus 2, and x plus 4 up, and I get negative 15. So from here, we're just going to finish up solving this problem. I'm going to combine like terms. We get 3x plus 6 is equal to negative 15. I can subtract 6 on both sides. That's going to give me 3x is equal to negative 21. And then divide by 3, and so x is equal to negative 7. Now, keep in mind, too, though, that the question was asking for all three integers, so one's not enough. I want to make sure that I finish with all three of them. So I have x is negative 7. I also want x plus 2. Negative 7 plus 2 is a negative 5. And finally, x plus 4. So negative 7 plus 4 is going to give me negative 3. So here are my three consecutive odd integers. Okay. Finally, well, second to finally, almost there. Football team has raised 82% of the goal for their new uniforms. They have $3,485. How much do they hope to raise? So I'm just going to kind of simplify this problem a little bit and represent this a little bit more easily, as 3,485 is 82% of what number? This is what I'm looking for. Okay. So again, I want to make sure that I define my variable. So we'll say x is going to be the amount of money we want, the amount we hope to raise. Okay, we'll call this money raised for now. And so I can do that sort of translating problem. So 3,485 is 82%, and again I can represent that as a decimal, 0.82, times what? Times x. That's what I'm looking for, the money raised. So to isolate my variable now, I'm going to divide by 0.82 on both sides. And once I put this into my calculator, 3,485 divided by 0.82 is going to be $4,250. Okay, that's my x. That's the amount of money I wanted to raise. Okay. Very last problem. On a map, 100 miles is represented by 2 inches. Now, two cities on the map are 6 inches apart. I want to know what, lost a T there, is their actual distance apart. So, last problem, I can set up a proportion. 100 miles is represented by 2 inches. So here's the ratio, 100 miles to 2 inches. Okay, and I want to keep in mind that 100 miles is actual distance, and the 2 inches is the distance on the map. So I want to make sure that I'm going to be consistent in the second half of this proportion. Okay, so I want to know what their actual distance is. I don't know it, so I'm going to call that x. And again, define my variable, say x is the actual distance. And on the map, it says they're 6 inches apart, so 6 inches is going to go down here. And finally, I can cross multiply to solve, so 2 times x is equal to 100 times 6. Divide by 2 on both sides, so x equals 300. So these two cities are actually 300 miles apart. Good job, you made it through your first video.